All right, so get ready, everybody, because today we're going deep into the world of 18th century science with Pierre-Simon Laplace.
Ooh,
This
Laplace.
guy, he was like a rock star of his time.
He really was.
Math, physics, astronomy, you name it. He basically like tried to write the rule book for the entire universe.
Yeah, and for his time, he did a pretty good job of it.
He did. He really did. And you know what's even crazier? You sent over these excerpts from this essay by Yergo Schneppat, and it's all about Laplace's connection to, get this, quantum technology.
It's really quite fascinating.
It's mind-blowing, right? I mean, it's kind of like finding out that, I don't know, your great-great-grandmother invented, like, this self-driving car or something.
Yeah. Schneppat really highlights this connection brilliantly, I think.
It does.
Because you see, Laplace, he was obsessed with this idea of a perfectly predictable universe. So one where if you knew the initial conditions of every single particle, you could calculate the entire future.
Whoa, hold on. So you're saying Laplace thought the universe was like, what, like a giant cosmic pool table? You
Yeah.
know, like if you knew the exact angle and speed of every ball, you could predict every shot for, like, all time.
That's it. That's a great analogy.
Wow.
And to Laplace, he even envisioned this all-knowing being, this Laplace's demon who could, who could do just
Well,
that.
the demon that knows all the secrets of the universe.
Oh, exactly. But here's where things get really interesting.
Okay.
Fast forward to the 20th century and, well, the rise of quantum mechanics.
Ah, quantum mechanics, yeah. That always seems to throw a wrench into things.
Always.
Yeah, it's all about uncertainty and probability, right? Like that whole anything is possible kind of thing.
It really is.
Yeah.
And Heisenberg's uncertainty principle, for example, basically says you can't know both a particle's position and momentum with perfect accuracy.
So much for Laplace's demon's perfect knowledge then, huh?
Exactly. So Laplace's deterministic universe gets a big, I guess you could say a big injection of quantum reality.
I love that, a quantum reality check.
And you have to wonder, I mean, what would Laplace have thought about that?
Oh, I'm sure, as Schneppat points out, he'd probably be pretty surprised.
Yeah, it's one thing to imagine a perfectly predictable universe. It's quite another to actually confront the reality of quantum mechanics.
Totally. But you know what's really fascinating to me is that even though quantum mechanics kind of shook up the very foundation of Laplace's worldview, his math is still incredibly useful for understanding the quantum world.
That is fascinating, isn't it?
It is. It's like, how can math that was designed for a perfectly predictable universe, how can that be relevant in a world that's all about uncertainty? It seems like a paradox.
It does, and Schneppat really delves into that paradox.
He does.
He looks at, well, for example, he looks at the Laplace transform. It's this mathematical technique that Laplace developed for analyzing signals and systems.
Okay.
And as he points out, it turns out it's incredibly helpful for understanding the behavior of light in quantum communication.
Wait, I'm getting a little lost here. So we're talking about something that was designed for predictability, and now it's helping us understand quantum communication. That's
Yeah.
like using a ruler to measure I don't know, like a cloud or something. It
Yeah.
just doesn't seem to make sense.
I know, it's a head scratcher for sure. But think of it this way, the Laplace transform, it allows you to look at a signal in two different ways. You can analyze it in terms of how it changes over time, or you can look at it in terms of its frequencies.
Okay, so like two different lenses to view the same thing.
Mm.
But I still don't see how that ties back to quantum communication.
Well, think about light. Light is often used to transmit quantum information, right?
Yeah.
And light is a wave, and waves have frequencies.
Right, okay.
So the Laplace transform, it helps us analyze the light waves that are used in quantum communication by looking at them through this frequency lens.
Ah, I see. So even though Laplace was trying to describe this universe where everything was, set in stone, his math gave us this tool to understand something as bizarre as quantum communication.
Isn't that something?
It's amazing.
It really is. And Schneppat, he digs into another example too.
Okay.
Laplace's work on probability.
Probability. Hold on, I thought Laplace was all about determinism.
Hmm.
Doesn't probability imply that things happen by chance?
Well, it's true that Laplace was a firm believer in a deterministic universe,
Right.
but he also recognized that we as humans, we don't have perfect knowledge.
That's for sure.
And so he actually developed probability theory as a way to deal with our own, our incomplete understanding of the world.
So it's like even in his deterministic world, there was still room for probability simply because of our limited human perspective.
Exactly. And Schneeppet, he brilliantly connects this to quantum mechanics. You see, the quantum world is inherently uncertain. We can't know for certain where a particle is or how it's going to behave. But we can use probabilities to describe its possible states.
So in a way, Laplace accidentally gave us some of the mathematical building blocks for a field that would ultimately kind of challenge his most fundamental beliefs about the universe.
It's a remarkable twist, isn't it?
It really is. It's like he gave us the key to unlock a door he didn't even know existed.
And what's even more remarkable is that this is really just the beginning of our exploration into Laplace's unexpected quantum legacy, as Schneeppet describes it.
Wow, I can't wait to dive in even further.
Well, then let's continue on this journey together. It's really, it's amazing to think about, how Laplace would react to something like a quantum
Oh,
computer.
right.
This
Uh,
machine, it's built on like the very principles of uncertainty that he tried so hard to like eliminate from his equations.
It's true. Schneeppet really does set up this, incredible thought experiment,
He does.
bringing Laplace face to face with the future of science. It's pretty wild.
It is. But before we get too carried away with all this quantum computer stuff, I think it's worth,
Yeah,
circling back to Laplace's deterministic worldview for a second.
right.
Schneeppet really emphasizes like how fundamental this idea was to Laplace's thinking.
Absolutely. He believed that the universe was like this incredibly intricate clock.
Cosmic clock.
Yeah, where every gear, every spring, everything was like working together in perfect harmony,
Hmm?
driven by these like predictable laws.
That's right. And if you could just understand those laws and if you knew the initial conditions of every single particle, you could theoretically calculate like the entire history and future of everything.
No surprises, no randomness, just like a perfectly predictable chain of cause and effect.
Exactly. Schneeppet does a great job of like laying out just how radical this idea was at the time.
It really was.
Because it really challenged people to think about like the nature of free will and,
Yeah.
whether our choices were really our own or if everything was already predetermined.
That's a pretty heavy philosophical question, maybe a little too heavy for us today.
Maybe. We're here to talk about science, not,
Right, not
not
philosophy.
philosophy. But, getting back to the science, how did this deterministic math of Laplace end up being so useful in a field like quantum mechanics, where things are like inherently uncertain? It seems counterintuitive.
Well, Schneeppet points out that, even though quantum mechanics kind of challenged Laplace's entire worldview, it didn't invalidate his mathematical tools.
That's right.
In fact, you could argue that his work on probability became even more relevant in light of quantum mechanics.
Oh, absolutely.
Wait a minute, probability. But isn't probability all about chance and randomness? How does that fit into this deterministic view of the universe that Laplace was so fond of?
Well, that's a great question. You see, for Laplace, probability wasn't really about some inherent randomness in the universe. It was more about dealing with our lack of knowledge.
I see. So it's like his demon, right? His demon could theoretically know everything and predict the future perfectly.
Right.
But we humans, we just don't have that luxury.
We don't. So probability was a way for us to like deal with these gaps in our understanding, to make predictions when we just don't have all the information.
So it's a way to cope with the unknown.
Okay.
And Schneeppet connects us back to quantum mechanics,
He does. Yeah.
saying that, the quantum world's inherently uncertain. We can't know for sure where a particle is or, how it's going to behave. So we use probabilities to, describe its possible states.
Exactly.
So Laplace, the champion of a perfectly predictable universe, accidentally gave us this mathematical framework for understanding a world that's, defined by uncertainty.
It's a beautiful paradox, isn't it? It really highlights the power of like abstract mathematical thinking, because sometimes these ideas, they can have these ripple effects uh, far beyond their original context.
That's so true. It makes you wonder, what other seemingly unrelated ideas out there are just waiting to be applied to new fields of science?
That's a great question. But, before we go too far down that rabbit hole, Schneeppet actually mentions some really specific examples
Yeah.
of how Laplace's math is being used in quantum technology today.
Right. We already talked about the Laplace transform and how that helps us, analyze light waves used in quantum communication.
Exactly.
But Schneeppet also talks about how Laplace's work on probability is, super crucial for designing quantum algorithms.
Yeah, so these quantum algorithms, they're basically the instructions that tell quantum computers what to do.
Right, right.
But how does probability play into that?
Well, as we've been discussing, quantum mechanics is like all about probability. Qubits, the building blocks of quantum computers, they can exist in this superposition of states,
They care.
meaning they can be in multiple states at the same time.
I know it sounds kind of crazy.
It does sound a bit like magic.
It does, but that's the nature of the quantum world, right?
Yeah.
And this ability to be in multiple states at once, it's what gives quantum computers their, incredible power.
Okay, so how do you even begin to design an algorithm for a computer that's, like, inherently uncertain?
Well, that's where Laplace comes in, as Schneeppat explains. By understanding the probabilities of different quantum states and events, scientists can actually design these algorithms that, exploit the power of this quantum superposition while also minimizing the risk of errors.
So Laplace, the man who tried to eliminate uncertainty from the universe, actually provided us with the tools to harness it in the form of quantum computers.
Isn't that wild?
It really is. It's like this cosmic joke
It's a
almost.
cosmic joke. Yeah, I like that.
Yeah, but Schneeppat goes on to say that Laplace's work on probability is also used to design like error correction systems for these quantum computers.
Yeah, so we're using his math to fix the very uncertainties that quantum mechanics introduced in the first place.
It's like, I don't know. It's like using a fire extinguisher to put out a fire that started because of like faulty wiring in the fire alarm system.
It's a great analogy, but on a more I guess on a more fundamental level, it really shows just how interconnected science is.
It does.
Ideas can travel across time and disciplines in the most unexpected ways.
This whole deep dive, it's been like a journey through history and science, showing how the ideas of one person, centuries ago, can have these ripple effects that are still felt today.
I agree.
But I'm curious, where does Schneeppat take us next?
Hmm.
What other insights does he offer about Laplace's legacy?
Well, we've talked a lot about the scientific and mathematical aspects of Laplace's work,
Yeah.
but Schneeppat doesn't shy away from the philosophical implications
Oh,
either.
no, we're getting into the deep stuff.
We
I'm
are.
ready for it.
And I think that's where our conversation needs to go next.
All right, so we've covered a lot of ground here. We talked about Laplace's math, his deterministic view of the universe, and how his ideas are finding new life in the world of quantum technology. But now, like Schneeppat suggests, let's get philosophical.
It's a fascinating area to explore, especially when you think about Laplace in the context of quantum mechanics.
Right. We've been talking about Laplace's demon, this hypothetical being that knows everything about the universe and can like predict the future with perfect accuracy. Schneeppat spends a lot of time unpacking this thought experiment.
He does, yeah. The demon really gets at the core of what Laplace believed about the universe, that everything is, in principle predetermined. If you know the starting conditions and all the rules, you know how it all ends.
So in Laplace's view, free will is just an illusion. It's a tough pill to swallow.
It is, but we have to remember that Laplace was working within the scientific framework of his time. Newtonian physics was king, with its emphasis on cause and effect.
And then quantum mechanics comes along and throws a wrench into the works.
Right. The uncertainty principle tells us that we can't know everything with perfect precision.
So does that mean that quantum mechanics completely destroys the idea of Laplace's demon and this whole idea of determinism?
Well, that depends on how you interpret quantum mechanics. Schneeppat points out that there are different schools of thought on this. Some interpretations try to reconcile determinism with quantum uncertainty.
Really? Tell me more about these interpretations.
Sure. One is the many worlds interpretation, which suggests that every time there's a quantum measurement, the universe splits into multiple parallel universes, each representing a different outcome.
Hold on, we're talking about multiple universes branching off constantly. My head's going to explode.
It is a wild idea, but
Yeah.
it's one way to hold on to determinism, right? Every possible outcome happens just in a different universe.
Okay. What else?
Well, there's also Bohmian mechanics, which proposes that there are these hidden variables that we haven't discovered yet. And these hidden variables would, make the quantum world deterministic after all.
So it's like there's this secret code, a set of rules that we just don't know about yet. And those rules make everything predictable again.
Exactly. But so far, there's no experimental evidence to support the existence of these hidden variables.
Right. Anything else?
Yeah, and then there's the Copenhagen interpretation, which is probably the most popular among physicists.
Okay.
It basically embraces quantum uncertainty as a fundamental feature of reality.
So no more clockwork universe, no more Laplace's demon with perfect knowledge of everything.
Well, not necessarily. The Copenhagen interpretation doesn't say that there aren't any underlying deterministic laws. It just acknowledges that our ability to know those laws is uh, limited by quantum uncertainty.
So maybe Laplace's demon is still out there rolling the quantum dice, but we just can't see the results.
That's a great way to put it, and I think that's one of the big takeaways from Schneppat's essay. It highlights the limits of our knowledge.
Hmm.
Even with these, incredible technologies like quantum computers, we're constantly being reminded that there are still mysteries at the heart of the universe.
It's humbling, but also really exciting, you know? Like, we're pushing the boundaries of knowledge, but we're still just scratching the surface of what's out there.
Exactly. And who knows what amazing discoveries await us as we, continue to explore this quantum world. Maybe one day we'll even figure out a way to have a chat with Laplace's demon and get its perspective on all of this.
That would be an incredible deep dive.
It would. But for now, I think we've given our listeners a lot to chew on.
We have. This journey through the life and work of Pierre-Simon Laplace has been amazing. From his belief in a predictable universe to his accidental contributions to quantum technology, his story really showcases the interconnectedness and the power of scientific ideas.
It does.
Hmm.
And a huge thanks to Yurgo Schneppat for his insightful essay. It really guided our discussion today.
Absolutely, yes. Thank you, Schneppat. And to our listeners, keep exploring, keep asking questions, and keep diving deep into the mysteries of the universe. Until next time,